Example 3, let y equals 4 sine theta. What transformation of the parent sine function is this? On a copy of figure 2-3i, sketch the graph of this image, sinusoid. Check your sketch by plotting the parent sinusoid and transform sinusoid on the same screen. So this is our parent function, y is equal to sine theta. And let us have the graph first. We begin with forming our x and y axis. So let's maximize the grids, okay? So to a certain extent. Okay, so these are my x values, and this would be for my y values. Let's make it like that. Let's maximize it, so let's put it here. Okay. These are my y values. Okay, so my parent function would be y is equal to sine x, and this y is equal to sine x could be taken with, having a graph here. So let's create a table for our y is equal to sine x, and this one would be for y is equal to cosine x. For sine theta. Okay, let's have the comparison of tables. But we could also use this. We could also graph the image function using our translations or dilations. But let us also use the tabular representations to get our f of the parent function y equals sine theta and the image function for sine theta. So let's label our x's. This is x, this is y, this is x, this is y. So let's use theta from 0 to 720 degrees, so that this is of a 2-period graph. So 0 degrees, 90 degrees, 270. I miss 180 degrees. 180 degrees, 270 degrees, 360 degrees, and then after 360 degrees plus 90, that would be 450 degrees, and then plus 90, that would be 540 degrees, plus 90, that would be 630 degrees, plus 90, that would be 720 degrees. So we just copy the same values for x, so 0, 90, 180 degrees, 270 degrees, 360 degrees, 450 degrees, 540 degrees, 630 degrees, 720 degrees. Now let's solve for our y. For the parent function, this is parent function y is equal to sine of theta, and this is y is equal to 4 sine theta. So if my x is 0 here, then that would be 0. And this is also 0. If 90, this is 1, and this is 4. If 180, this would be 0. 0. 270, this would be negative 4. This is negative 1. 0, 0, 1, 4, 0, negative 1, 0. So this is 0, negative 4, 0. So you notice that for y equals sine theta as our parent function, this is our parent function, this is our image function. So as you notice, your maximum value, which is 1 here, becomes a maximum value of 4 here. And negative 1 here becomes a minimum value of negative 4 here, and so on and so forth. But their points of their zeros, their intercepts remain the same for x-intercepts. The x-intercepts remain the same. So if this is my x, this is my y, I'm going to label all the degrees or all the x values. So this would be 0, 90. Let's make it 90. This is 180, 270, 360, and then we have 450, and 540, and 630, 720. And here we have 0 to positive 4. We have 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. So let's plot the points. For the parent function, we have 0, 0. So first point is here. Second point is 1 and 90 degrees. So it's here. Next is 180 is 0. And we have 270, negative 1. 360 is 0. 450 is 1. And then 540 is 0. Negative 1. And then 0. So if I'm going to get the curve here, my curve would appear like this. This would be my parent function, the graph of my parent function. Okay, so I have to make a good curve here. Okay, so we have this. Where are the others? Where are the other points? Okay, I think I deleted them. So it would be like this and like that. Okay, now it's time to connect all of the points. So this is the graph for the parent function y equals sine theta. Now I will plot the function y is equal to 4 sine theta. This is the image function. So I will graph it in green. So if 0, it is still 0. And if it's 90, it's 4. So it would be here. And then 0 again. And then negative 4, 0, and positive 4. And then 0, and negative 4, and then 0. So look at that. Okay, now I'm going to connect all of the points. So look at my graph. I couldn't see. So if I'm going to connect the graphs, so connecting all of the points, I'm going to connect them. I'll start here so I would see clearly the points. So, okay, I want a smooth curve. There you go, that's beautiful curve. Okay, now I've got the curve, okay? And it's not so perfect, but look at the curve. So if I would take out the grids, you can see the difference, okay? Now, there is another way to plot the image function without using this table. And we could use the, what do you call this? The dilations. Remember that this function here, 4 sine theta, has a vertical dilation, or a vertical stretch of 4. So for each of these points here, they will be stretched to 4 times from the axis of from the x-axis, okay, from your balance axis, okay. So in this case, if this is 1, we're just going to count 4 times of 1 is 4, 1, 2, 3, 4. So we put or replace the first point here only on those not in the intercepts, not in the x-intercepts, okay? Because we are stretching the graph. If we're going to have a vertical, translation, then we could translate. But in this case, we don't have any translation. So the places of the x-intercepts remain the same. They will not be translated. So all we need to do is to stretch all of those other points aside from those x-axis. Okay? So in that case, we did this curve. So just to highlight, this is our y equals 4 sine theta, meaning that the amplitude of our sinusoidal function, parent function, sine theta, y equals sine theta, increases by a factor of 4. So it was stretched to a factor of 4. So this is the answer for example number 3.